Hello, can you guys hear me?
Yes, sir.
Yes, sir.
Thank you. Thank you.
Hello. Prasanna? Prasanna? Are we audible? Oh, thank you. Prasanna, am I audible? ಎಲ್ಲರಿಗೂ ಶುಭ ಮಧ್ಯಾಹ್ನ. ಕರ್ನಾಟಕ ರಾಜ್ಯ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಮಂಡಳಿಯ ಸುವರ್ಣ ಮಹೋತ್ಸವ ವರ್ಷಾಚರಣೆಯ ಜುಲೈ ತಿಂಗಳ 6ನೇ ವಿಶೇಷ ವೆಬಿನಾರ್ ಸರಣಿ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ತಮಗೆಲ್ಲರಿಗೂ ಆದರದ ಸ್ವಾಗತವನ್ನು ಕೋರುತ್ತೇನೆ. Very good afternoon to one and all. Distinguished guests, respected speakers, officials from KSCST, representatives from various science and technology councils across the country, esteemed faculty members, students, and all other participants. It's my privilege and honor to welcome you all to this Golden Jubilee celebration of Karnataka State Council for Science and Technology through a special webinar series program. Today, we are gathered virtually to participate and celebrate and organize a webinar on the topic and theme, climate change and sustainable development. We are deeply honored by your presence and thank you very much for joining us today. We are privileged to have with us today eminent speakers from Indian Institute of Science, Professor Lakshmi Narayana Rao, Associate Professor, Center for Sustainable Technologies, Associate Faculty, Interdisciplinary Center for Water Research, Associate Faculty, Materials Engineering, Indian Institute of Science, Bengaluru. And also Professor Bhupendranath N. Goswami, Honorary Professor of Excellence, Guwahati University. To begin with, now I would like to invite Professor Ashok Raju, Secretary, KSCST, and Professor, Department of Materials Engineering, Indian Institute of Science, to deliver his opening remarks, welcome address, and overview of the program. Over to you, sir.
Good afternoon, everyone. Welcome to today's webinar series. So I think this is the sixth one in the series, and every month we have two speakers speaking on a special topic that we pick, which also represents the work that we do here at KSCST. And just to introduce KSCST, we are celebrating our Golden Jubilee this year. It was established in 1974. And as part of the Golden Jubilee celebrations, we are carrying out this special webinar series along with other activities throughout the year, which we hope will culminate in a grand celebratory or a celebration that we plan to have in the coming months here in IISc. Just to introduce you to the activities of KSCST, for those of you who are not familiar with KSCST, we are a registered society, autonomous organization under the Department of Science and Technology, Government of Karnataka. And we have a governing council, which is headed by the Honorable Chief Minister of the state. And then we have the Honorable Minister of Science and Technology as the Vice President, along with the Director of Indian Institute of Science as the Chairman of the Executive Committee. So we have two Vice Presidents, we have and a President. And the Executive Committee runs the day-to-day activities of the council. And so the idea was, when it was started, to play a proactive role in the application of science and technology with the support of IISc and other academic and R&D institutions. So at that time, whatever technologies were there, mainly under the Center for Sustainable Technologies, which also happens to be today's theme, those were the technologies that we wanted to take to the people, actually to the rural areas of especially Karnataka at that time. And it was a very successful program that was launched. So we had chulas, we had other kinds of technologies, mainly for cooking and other kind of activities. And so there were a lot of activities, and that has now we have moved on. I mean, we have added a lot of things as the society has developed, science and technology has developed over the years. We have added several problems associated not only with science and technology, but under these themes of water, energy, environment, agriculture, education, housing, geo-ICT, IPR, etc., for sustainable development of the state. And we assist the government as and when they require, both the state government as well as the central government under the DSTA. So we have been doing this. And over the years, we have received 3 national awards also for outstanding performance in the area of energy conservation, geospatial technology, and IPR. So that's a little brief thing. And these are all the major sectors that we cover on the right side of the screen, as you see. And collaborating organizations, there are several of them across the state, independent bodies, autonomous institutes, government institutes, as well as line departments of the government of Karnataka. Here, I just want to highlight the main activities that we have. So we look at geospatial technology for informed decision making. Under this, we have the NRDMS, the Natural Resources Data Management Centers at the district levels. So the people from KSCST work under the Jilla Panchayat. We have the Karnataka Geo Portal, and then the digital heritage 3D laser scanning of the monuments of museums and forts, which is a very recent activity we have started, and it's going on very well. And in terms of water, we focus on rainwater harvesting, watershed development, drinking water, and then traditional water harvesting systems. In fact, in rainwater harvesting, we have set a very nice, we have taken a leadership role, I should say. And, we have been able to convince and also train people across, not only in Bangalore, but across the state. And we are also training people throughout the country also. For the education sector, we support student science projects, which is our flagship program, which we have been running for 48 years now. And where we support student projects through small funding. And then finally, they are selected for an annual exhibition, and some prizes are given. But it's a very nice activity, and people value it a lot over the years. Then we have established e-learning centers, digital literacy programs, then teachers empowerment program, and then Science for Rural Karnataka with IISc, where the students of the PhD students of IISc, they participate in this activity. So they help to teach the children from rural areas and try to inculcate and build a scientific temper amongst that. In the alternative building technologies, along with CST, we have been promoting green buildings, which has helped in construction of more than 20,000 houses. Totally about 1 lakh people have been trained across the state. Similarly, in renewable energy, we do consulting and provide detailed project reports, DPRs in wind, microhydel, bioenergy, solar, and also we provide end-to-end solutions on renewable energy projects. We also engage with experts so that it's like a joint activity where the experts will help us in bringing these projects to a logical conclusion. In terms of patent information, we have been creating awareness across the state. It has been very successful. We have set up close to 90 IP cells across various colleges and universities, and it's an activity that is going very well. We also help to the extent of doing, say, in the initial the surveys for the students, and then we assist them in taking it forward and filing it. Along with that, we do outreach programs on important days like National Science Day, National Mathematics Day, the World Environment Day, right, the World Biofuel Day, and I think we even celebrated the Space Day also, I think in the last year. So we are continuing with that. These are also huge attractions for students. We bring them to the institute. We celebrate this across all the district centers across the state. Through our networking that is present. Finally, we were handling a couple of centers of excellence on behalf of the government of Karnataka in cybersecurity and aerospace, which are now come to a conclusion. But then the cybersecurity is being run in a different form in IISc itself. And then we also assist the government in formulating the what you call the advertisement and call for applications, screening them, and then a committee which is headed by our director looks at the nominations, and then we select the every year best scientists and engineers at different age groups, and we do that completely on our own with the help of the government of Karnataka. But this is on behalf of the government of Karnataka. And then we also are, in the recent past, we have been promoting this non-timber based products, especially for the tribal communities in Karnataka in 3-4 districts. It's been very successful. We have helped them set up their own factories for harvesting, honey, then amla, shikatai, and so that we help them package it and sell it so that they also get some a small amount of profit from that, which they are currently not able to do it, and also it is not reaching the market properly. And last but not the least, environment, nutrition, and SCST cell. So under these heads, we have been running a large program in Yadgir, which is a aspirational district, fortified food using biodryers. And it is now coming to a conclusion. We have set up in such a way that we are able to produce fortified foods, dried food actually, so that it will be supplied to school children and women actually who are malnutrition, and so that they are able to enhance their health. And NGO is helping us in creating the awareness and also developing or creating a database where we are able to see what was the state before this project started and what happens afterwards. On a similar line, the SCST cell was established with the help from the Government of India, and there we are primarily focused on skill development and improving the livelihood of the SCST community. And again, it has been a huge success. We try to touch all the parts of Karnataka as much as possible. And not only we don't do all the activities in Bangalore, but we try to reach out to people in far-flung areas And because of that, I think KSCST has been very successful in implementation of all these activities. And it has been appreciated in different forms, both at the state level as well as the central level. And we hope to continue to do this in the coming years. And now we have reached a kind of a landmark of 50 years, and which we are celebrating now. So with that, I think I will stop my my few thoughts that I wanted to share about the activities at KSCST. And I think we have two eminent speakers today is talking about two different subjects. And maybe should I start with the first one? Huh? Professor Lakshminarayan, are you ready?
Yes, I am ready.
Okay. So the first speaker actually gives me great pleasure, to introduce Professor Lakshminarayan Rao. I have known him since he joined for his master's degree in my department, that is Department of Materials Engineering. I can't recall the year, but he was there. I mean, when I was also young at that time. So he did his master's in my department, then went to Canada to do his PhD. And I think after a brief stint as a postdoc, he returned to IISc as a faculty. And now he has successfully established his lab at the Center for Sustainable Technologies. And one of the prime areas that he works in is related to water, different aspects of water treatment and other things, contamination or removal of contaminants and things like that, and making modifications to existing processes in such a way that the process becomes more efficient. So Professor Lakshminarayan Rao also has been closely associated with KSCST, helping us in various other activities, including the student projects program. And he's kind of a live wire on this campus, very active, always present. Whenever you ask for any help, he's there. And today we wanted him to share his thoughts so that it fits into this theme, and he readily agreed for that. And so with that brief introduction, Professor Rao, I would like to invite you to give your talk.
Sure. Yeah, definitely. Thank you. I'll take another next half an hour to maybe 35 minutes. I will run through. First of all, thank you for the kind introductory words, Professor Raikor. Yeah, it was between 2002 and 2004. I was associated with as a student of Materials Engineering Department. Fantastic time I had there. Yeah, for the past 6-7 years, I've been working since 2018. I started looking at water and wastewater in IISc, and we think that we have done some contribution to our state and to country at large. And I will share some of our thoughts on how Bangalore, a city of about now close to about 1.5 crore people, living, how do we manage our water, what happens, where do we get our water from, and what do we do with our wastewater. So it's a quick introduction about that, and at the end I would like to have some question answer sessions. So next half an hour I'll discuss about our experience, my experience with water, and then what we have learned, and how city like the city like Bangalore manages the water. Okay, I'm sharing a small PPT. Hope you guys are, and then hope there is no ribbon or anything like that where you see the slides properly shared. And I hope that. So I'll continue. So basically, we manage city as a city. Bangalore has been doing very well in managing its water resources and also reusing it. So I will give a glimpse of that. So before I talk about Bangalore, I thought I should also talk about IISc. So IISc, we started, as you all know, it started in 1909, and at that time the campus looked like that. And it was all because of the funding coming from Tata and Government of India, and given land from the Rani there. So so the queen is the one who gave, although it was in the name of the king. The lady, the mother of the king, actually she gave the land for us. So and then with that the institute started. Today the institute is the #1 institute in research We are ranked number, this is the 2023 data, but the new data are also there. And, we are doing well as an institute. We are a very big, we are one of the institute of eminence of the country, and we have been doing very well in India. So this is how it was when we started, and this is how it looks. So it's like a green space for Bangalore. So a lot of tree cover and forests, although it remains like this, and some of it has gone, but mostly it remains like this. So we are happy about that. There are got multiple departments, you name it, right from atmospheric and oceanic sciences all the way up to infrastructure, sustainable transport, urban planning, all departments. We have a presence. There is some research going on in these areas: mechanical sciences, physics and maths, electrical, electronics and computer sciences, chemical sciences, biological sciences, and interdisciplinary center. So all these are different centers or different streams under which there are different departments. So as an institute, we have our presence in all sectors of research. So CST, Center for Sustainable Technologies, it was started in 1974. At that time, it was called ASTRA, Application of Science and Technology for Rural Areas. You were given a village, actually, faculty from IISc went and stayed in a village called Ungra Extension Center, and this was with us all the way up to 2011. And we developed technologies in the areas of biogas, rural energy, forestry, rural sanitation. And that is what Professor Raikur was referring to in the beginning, that there were a lot of support from CST at that time, Astra to KSCST, to disseminate the technologies developed by Astra. And, then we had chulas, we had rural sanitation, clean drinking water projects, low carbon technologies for housing. And in 2004, Astra, 2003, 2004, Astra became CST, Center for Sustainable Technologies. And today we have an MTech program, a PhD program, and, and then obviously the master's degree. So we work in all areas. So here was the Ungra Extension Center. So all the projects that were started. So biogas was started, and then we were making electricity using the biomass, the wood, and people were actually paying ahead, 1 or 2 days ahead, to get their power, both for running ragi hittu mills or hittu mills, the flour mills, and also for water, for agriculture, water from bore wells. So a system was set up. Chulas, obviously, better, efficient chulas were designed, and then it was disseminated. So more than 1.5 million stalls were built using these things. Dryers for cabinets, for food dryers were also made, and this technology was also given so that agriculture produce can be stored. Drinking water units for removing of fluoride and nitrates were also developed and disseminated. Alternative building technologies, when Bhuj earthquake happened in 2003, 40,000 buildings were constructed using alternative building technologies. Very quickly, these houses were built and, and disseminated. Toilets were built, appropriate sanitation technologies were built at a very low cost so that people can use it for their daily needs. Today, the Center for Sustainable Technologies has 4 main pillars: energy, water, environment, and habitat. We have faculty working on all of these things, and it's a very young team of faculty members who work on these areas. So I work on energy, I work on water, and I also work on environment. So these are some of my expertise. We'll talk with that much introduction about IISc and CST. We'll talk about our city, Bangalore. Where do we get our water and how do we manage our water? So let us look at that for people who don't know where is Bangalore. We are part of Karnataka. It's the capital of Karnataka. Karnataka is down below here, and Bangalore has these many districts. And we get, so here is our Bangalore, and most of our water comes from Mysore, which is the Kaveri River. So that's our lifeline for water. So some images of Bangalore, so beautiful city. Here are some data. So about 8,000 square kilometers is basically 800 square kilometers is your total area. Metro, if you put everything, it is 8,005 square kilometers, but your metropolis itself is about 750 to 800 square kilometers. Okay, so that is how the Bangalore map is that you can see. Bangalore, BWSSB, the Bangalore Water and Sewage Board, is what distributes the water. So that's also called Bruhat Bengaluru Mahanagarapalike. So that's your BBMP map of Bangalore. There are different, core area. Then there are 8 ULB villages which are shown over here, and then 110 villages. So if you put all of this together, that's about 800 square kilometers of area that Bangalore is encompassed of. And then there are about between 1.4 to 1.5 crore people live in this area. They all have water demands. Now we need to get them water. They also generate a lot of sewage. That sewage has to be treated, and then sewage is the wastewater that you and I produce in our houses. That also has to be collected and has to be treated, and it has to be disposed of or reused in a very proper way. So that's the challenge, and that is how the city manages it. And then we are going to look at it, how it does that. So Kaveri is the only source of water supply for us that flows in Mysore. And we pick up water from Kaveri, we treat it in a place called TK. There are multiple treatment places. This is one of the pictures of TK, where we see that, and that's a water treatment plant which is running. Here is the pumping station at TK. And bulk supply of water to Bangalore started from 1933. So that was the Arkavati project, which is the Tippagondanahalli project, which started in 1933. There is now plans of reviving it, but currently it is still under revival. So it started at that. Now, after that, from 1974 to 2024, we have different stages of Kaveri. Stage 1, phase 1, 2, 3, 4th phase, phase 1, 4th stage, phase 2, phase 3 again, then the TJ. So these things have come. Total supply, the capacity is 2,330. So that's the capacity of the water that can be million liters per day. So that unit here is very important. As you can see, let me take my pointer so that it becomes easy. So the pointer, so we get so many million liters. So million is 1 followed by 6 zeros. So you should put 2,330 followed by 6 zeros. So many liters every day. So the water supply bill for Bangalore every day is about 2 crore rupees. So that is how much money BWSSB is spending to get the water to Bangalore every day. Currently, that's the installed capacity. We are getting anywhere up between 1,440 to 1,600 million liters every day. So let us say 1,600 million liters of water. Bangalore also heavily relies on groundwater. So we pump a lot of groundwater. Approximately this number is slightly increased now. This is about 800 million liters. So 1 million liter every square kilometer. So roughly that is the number. Every square kilometer that we have, we pump 1 million liters of water, 1 followed by 6 zeros liters of water every day from Bangalore's Mother Earth. So that's the kind of water that we have. So let's say 1,600 plus 800 is 2,400. Between 2,200 to 2,400 million liters of water is consumed every day in Bangalore. So more details. So we get from Kaveri, then we have water being pumped. So the total length of water supply pipelines is about 15,000 kilometers. So many 10.95 lakh houses are served. Approximately every house which is served by BWSSB is given about 108 liters of water per day. So much water is being delivered. So here are all the details. I'm not going to look at all these details for you, but you and I should remember that if we are 4 people in our house, so that is 108 multiplied by 4. So 400 plus 80 plus 32. So 432 liters of water comes to us every day from BWSSB. That is what they are supposed to deliver, and they do deliver that much water to your house every day. So you and I carry a liter of water. This water This bottle is about 1 liter. So 500 such, 432 such bottles come to your house every day. So that's what I think we should remember. How much does it cost us? I think the cost data is also there somewhere. And we also generate lots of wastewater. So the cost, I think, should also be there somewhere. I will, it's one of the slides has the cost. So it costs BWSSB about 50 rupees every 1,000 liters. So to get you to get 1,000 liter of water from Mysore to your house, BWSSB costs you about 50 rupees. But for domestic use, if your consumption is less than 20,000 liters a month, they're charging you only 6 rupees. So the remaining 44 rupees is actually given by the government for you, as a subsidy. So that's what we should remember whenever we use BWSSB water carelessly, washing our cars, washing our floors, flushing down the drinking water quality water to use it in our flush. Each time we urinate or we pass the feces, we flush it. So 4 to 8 liters of water goes down the drain. For every 1,000 liters, they are paying you 44 rupees. So you should keep that in mind each time you flush using drinking water quality water. So all of us also generate sewage. So to collect the sewage, BWSSB has set up about 12,000 kilometers of sewerage network. There is 3.91 lakh manholes are there, and people work to generate or to collect the sewage. So the total sewage generation is about 1480 MLD. The balance is getting lost. Your sewage networks are not complete. So there is also losses of sewage network. Out of about 2,200, we are only collecting 1480 as of today. The remaining goes uncollected. Either they're lost or the leaky networks leaks into Raj Kalways, and that's why you see sewage sometimes flowing in this Raj Kalways. So the average treatment today, Bangalore treats 1250 million liters of the collected sewage. So that is what is the situation. We have total number of STPs the Bangalore has is about 34, and then there are another 28 STPs under construction, so that we reach close to about 100% sewage collection. That's the aim, and BWSSB is working towards that. It's always a catch-up game. To build an STP, centralized STP, sewage treatment plant, it takes about 5 years. In that 5 years' time, and your sewage generation capacity has increased. So it's always a catch-up game for BWSSB to meet to ensure that all the sewage generated is captured and treated. So here is a map of 34 STPs which are located strategically so that wastewater is collected through gravity predominantly and treated. So these are all the STP locations, starting from your centralized location of Kaban Park all the way into KC Valley, which is 248 MLD, Malasandra 75 MLD. So it is strategically located in the outskirts of Bangalore, because Bangalore is like a cut orange kept upside down. So the highest point is somewhere behind IISc, and it drains into three locations or 3 valleys, which is called the KC Valley, HN Valley, and the V Valley. KC Valley is the Koramangala Challagatta Valley, V Valley is the Vrushabhavati Valley, and the HN Valley is the Hebbala Nagasandra Valley. So these are 3 major valleys where the water flows out of Bangalore, and BWSSB has set up the STPs around Bangalore so that it is collected and treated and then disposed of. So that is how the sewage networks are in Bangalore. So what do we do? Where do we get our flush supply? As I said, it started, if I go back even before TG Halli 1933, it started in 1873, Miller series tank. That's how it started. 1896, Hesargatta systems were started. At that time, our capacity was only 0.25 million people, and they said they will only need 55 liters per day. So with that much, they started it. Our official supply of water, it started, in a big way in TG Halli tank in 1933, and from there on, we are doing from 74 to 2024 using the Kaveri stages, stage 1 to stage 4 right now. Okay, so that's how the water supply to Bangalore is. So these are the pictures of Hesarghatta. This is still working. We were asked to revive it not too long ago. So that's the Hesarghatta tank 55 LPCD system, pumping system. That's the TG tank. This is also we are reviving. We are helping BWSSB Tippagondanahalli tank to revive this tank, which comes under the Arkavati, Arkavati river. So this also will supply the water. So this also is being under revision right now. Okay. Again, Kaveri. This is another water treatment plant. I told you in TK. One more picture of that. There is always a catch-up game between demand and supply. The city is always growing. There is always a demand and supply catch-up. By 2025, we still have about 500 MLD catch-up that we have to do because the city keeps on growing. Okay, so with the help of KSCST and CST, there's a lot of work that has done to ensure that the houses in Bangalore are also doing rainwater harvesting, and also make sure that they contribute to reduction in the per capita water consumption. So rainwater harvesting is a concept that was developed in conjunction with KSCST. I think CST also had a role to play, where a simple system was designed and disseminated. KSCST has done a fantastic job in educating people on how to harvest our rain. So Bangalore receives close to about 1,000 mm of rainfall on an average in a given year. So if you set up your rainwater harvesting efficiently, and that was also a rule passed with the Pollution Control Board and also the BWSSB, when you want to get fresh connection of BWSSB, you need to demonstrate that you have rainwater harvesting systems installed in your houses, where you harvest the rainwater and either use it directly or use it for recharge of groundwater. Such a system exists, and almost all houses, at least for namesake, they have done it. Majority of them, although majority of them have done it for namesake, there is always a fraction of people, and this fraction continues to grow every year, that they have actually done it. They actually harvest the rainwater, and they are reliable on rainwater for complete year. So we know of houses, they don't even have BWSSB connections. They completely weave off rainwater, both for their drinking purposes and for domestic purposes. And there are houses who harvest rainwater and use efficiently. So this initiative, though it started, and then maybe it started as an eyewash, but now it has really picked up. Last year, when there were issues with no supply of water, when our water became scarce, so this became the efforts of this were very seen. So houses who were doing rainwater harvesting, they had their bore wells functioning and not lost. Okay, so that's what our experience has been. So Bangalore also promotes rainwater harvesting. How does wastewater in Bangalore gets treated? So we will look at that in the next 10 to 15 minutes, and I'll stop and we can take some questions. So as I said, Bangalore today has 34 STPs. One of the contributions that we have made is that these STPs were all designed, they all were designed as, they have organically grown. As the city keeps growing, STPs are also growing. So the original STP was actually designed by ISC and installed in the Vrishabhavati Valley somewhere in the 60s. And that was functioning till last 2 years ago. Because of space constraints, they scrapped it. Then majority of STPs came around 1970s, 1980s, which were based on activated sludge process. These were all designed for old discharge water standards. And when the new discharge water standards came, they were not able to comply with. So that is when IISc intervened, and then we told them that you can do some process modifications so that you can use the existing STPs and still generate high quality treated water, which can be recycled for, again, augmenting groundwater. So that is the contribution that we did to BWSSB. They accepted our recommendations, they implemented it, and for everybody's surprise, and we know that it would work. For them also, they were also happy to see that our recommendations actually worked, and the wastewater quality, the treated wastewater quality improved, so that they could recycle it for filling up of tanks in and around Bangalore. So that is what is going on. As of today, Bangalore stands as the Asia's largest wastewater recycling city. Okay, so we recycle a lot of water. So out of this, 80% of the water is treated in centralized treatment plants, 13% is decentralized treatment plants, and 76% of Bangalore's treated wastewater is recycled or reused. Bangalore reuses on a daily basis, as of today, 865 million liters of water. By the end of December this year, we would add another 310, making it close to 91% of treated wastewater being reused for augmenting groundwater levels in and around Bangalore. So there are three major projects going on: the KC Valley project, the HN Valley project, and the V Valley project. And also BWSSB is also looking at filling up the Bangalore tanks or keres of Bangalore with treated wastewater. So these activities are going on. So when in around 2000, when previously Bangalore was somewhat like this, so the treated wastewater or the untreated wastewater would flow in these nalas. So this scene, people driving to Mysore would remember. Rushabhavati Valley looked like this, and there was foam coming out of Bangalore. Bedandur Lake also had similar problems. But right now, you don't see this problem. You don't see this kind of foam going on. That's because of the efforts done by BWSSB predominantly, with the advice from IASC, from our team. You don't see such foaming water flowing through Rushabhavati. Have we completely addressed it? No. We have majority addressed it. There are still some work needs to be done, and we are in the process of doing it. Right now, you see something like this. Cities, the treated water from Bangalore is used to recycle in Kolar. This is from of the treated water. You will see the lotus being grown over here, and it is considered, if lotus is growing in water, the water is of good quality. So here is a picture from the treated water being recycled to improve the groundwater levels in Kolar. This is one of the Kolar tanks. So the water which is being treated in BWSSB meets the most strict standards of the country, which is called the NGT standards, which asks for COD less than 50, and then BOD less than 10, and total nitrogen less than 10, and it meets the values, meet this, the treated water meet this quality. And there was a lot of concerns about heavy metals. You and I don't consume heavy metals. You and I don't discharge heavy metals. This is mostly sewage. So the sewage, actually, the treated water does not have any heavy metals in it. And this we have been telling for the past 5 years. And the treated wastewater, starting 2019, the KC Valley project, which is the recycling of treated wastewater from Bangalore, is going on. For the past 6 years, people of Kolar have been benefited by this treated wastewater from Bangalore. So here is a picture of one more tank, which is filled in Kolar. Kolar is about 50 kilometers away from Bangalore. So Kolar, before the starting of this project, had groundwater levels depleted all the way up to 2,000 feet and beyond. So people would drill up to 2,000 feet. Water was not available. Drinking water was not available. Forget agriculture. The water, even if it was available, was very, very small quantities, and it had very high dissolved solids in it. The TDS levels are very high, making it unfit for drinking. So all villages in Kolar, or all Gram Panchayats of Kolar, were spending crores of rupees getting water from far off places. So Bangalore decided that we have our treated wastewater. It meets the drinking water. It meets the discharge water standards. So why don't we start using this water and fill these tanks and augment groundwater? And that's what was done. So here is one of the tanks filled with treated water from Bangalore. And you can see how the water looks and how water, when it started going back, how it has brought back the life. So the water looks like this in this beaker. So it is filled in this S. Agrahara Kere. So the project was, Kolar has about 4,000 tanks or keres. Out of 4,000 tanks, as phase 1, they identified 152 tanks, and they filled these tanks, and they asked IASC please help us scientifically monitor this project. So we have been involved, myself, Professor Mohan Kumar, Professor Chanakya, we have all been involved in giving them technical advice on how to monitor these projects and how to execute this project. And that is what we have done. And this is how the water quality looks like. In this cluster, there are about 14 tanks or carriers, which is filled. Similarly, there are, as a phase 1, 142 tanks were filled. And in phase 2, another 272 tanks are being filled. So this is going on for the past 6 years. This has brought back life. So the carriers, which looked completely dried up, now looks beautifully filled with water. And this has brought back life. You can see that treated wastewater flowing. Lot of things have come back because of this water. Okay. So what has happened? Your income levels of farmers have gone up. Your fish production has gone up because all these tanks are auctioned off for fish production. Because fishes are there, your migratory birds have come back. Migratory birds have come, so tourism has gone up. Now you have more groundwater, so people who are doing only 1 or 2 crops a year, now they do 6 crops a year. They are all doing. Kolar was the vegetable basket of Karnataka, or vegetable basket for Bangalore. It has come back to that. Kolar people are now growing vegetables and flowers. They are exporting it outside the country and for also within the country. They're, because now they have more agricultural activities, their agricultural incomes have nearly doubled in some of the places. Their livestock, January means they have more houses and more cows and pigs and chicken growing in their places. So lot of positive changes have come back because of supplying treated wastewater from Bangalore, and circular economy has happened. Thanks to this project, which happened during COVID, people who went back during COVID remained there because now they have their borewells rejuvenated, groundwater levels have improved. So they have water in their farmland, so they can take up agriculture. They have removed eucalyptus and they have gone for now vegetables and cereal growth. And you can see in some of the categories, the incomes have nearly doubled. Initially, they were resisting water. Now they are demanding more and more water in the people of Kolar. You can see some pictures, flowers being grown, fishes, migratory birds, sericulture has improved so that you can see pictures of that. Fish production, each fish are a few kilograms, piggeries, chicken, cows, migratory birds, flowers, so a lot of positive changes. So here is the contrast. So this is how Kolar was, and this is how Kolar is now because of this project. So this is the treated wastewater going in. Tanks which were dry has become full of water. People have more access to water. Water is life. Life comes back, so people are enjoying. Before previous people were suffering. Even the dug wells have come back, Kalyanis have come back, water levels have improved, migratory birds have come back. So lot of things because of this project. Okay, so circular economy has come back in this place. Here is a small video of what kind of vegetables and flowers they are growing and how treatment and reuse of recycled water has become a model for the rest of the country. Seeing the success of this project, which is the KC Valley project, where it recycles 440 million liters of water. Karnataka also implemented HN Valley project in 2022. Then they did V Valley project right now they are doing. So this project has got a lot of awards. People from all over India, the Central Water Commission has come and visited this project multiple times. Now they are making this water recycling project as a model project for the rest of the country. So we are asked to come up with guidelines of how to implement such a project for the rest of the country. And we are working on making this wastewater recycling as a model project for the rest of the country. So I will stop here. With a statement saying that when the civilization started, we were not caring for waters. Or when I was a kid also, we were not caring for water as much. Using drinking quality water for flushing down your urine and feces is a crime that humankind cannot afford. Cities like Bangalore doesn't have to be sink of resources where we get water, power, manpower from different places and we consume. Cities like Bangalore, by implementing such projects, can become a source of treated wastewater, which will augment groundwater, augment agricultural activities, support circular economy. So this project has shown that. Many people have contributed to the success of this project. I would like to thank all of them. And with this, I will stop here. And if there are any questions, I will be happy to answer. Thank you for giving me this opportunity, KSCST. If there are any questions, I'll be happy to answer, sir.
Okay, thank you, Professor Rao, for the nice talk. Especially this is a topic, I think, which touches our lives, everyday life, I should say. And if anybody has any questions, please feel free to ask me. Maybe one or two questions. Yeah. Yeah. Yes,
sir.
Yeah,
Good evening,
Harish.
sir. Good afternoon. I am from Advance College, Mudugudire. So we have plenty overflowing water here because of heavy rain. So is there any opportunity for us to implement such kind of things so that we can improve productivity and agriculture? Such kind of any projects are there? We are ready to collaborate.
Yeah, sure. I was with actually, NIT Suratkal.
Yes, sir.
I visited about a year ago. They have excess rain. They have more water during rainy months. And
Yes,
during summer months, they have no water. So it
Yes,
was so and so that they had to send out students home during summer months. And
Yes,
it's like a ಕನ್ನಡದಲ್ಲಿ ಹೇಳ್ಬೇಕಂದ್ರೆ ಎಂತ ವಿಪರ್ಯಾಸ. ಸೊ ಮಳೆಗಾಲದಲ್ಲಿ ತುಂಬಾ ಮಳೆ ಇದೆ ನಿಮ್ಗೆ, ಸಖತ್ ಮಳೆ ಬರುತ್ತೆ, ಅವಾಗ ನಿಮ್ಗೆ ನೀರ್ಗೆ ಏನ್ ಯಥೇಚ್ಛವಾಗಿದೆ. ಬೇಸಿಗೆ ಕಾಲದಲ್ಲಿ ನಿಮ್ಮ ಹತ್ರ ನೀರಿಲ್ಲ, ಬಿಕಾಸ್ ನೀವು ನೀರೆಲ್ಲ ಸಮುದ್ರಕ್ಕೆ ಸೇರ್ಕೊಂಡಿದೆ. ಸೊ ಲಾಟ್ ಆಫ್ ವಾಟರ್. ಬಟ್ ಎಷ್ಟಿಗೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ದ ಡೈರೆಕ್ಟರ್ ವಾಸ್ ಟೆಲಿಂಗ್ ಮಿ, ಸರ್ ನಾನು ಸ್ಟೂಡೆಂಟ್ಸ್ ಅನ್ನು ಮನೆಗೆ ಕಳಿಸ್ತಾ ಇದ್ದೀನಿ ಸರ್, ಬಿಕಾಸ್ ನಮಗೆ ನೀರ್ ಕೊಡಕ್ ಆಗ್ತಾ ಇಲ್ಲ ಅವ್ರಿಗೆ ಕುಡಿಯಕ್ಕೆ. ಸೊ ಐ ಆಮ್ ಆಸ್ಕಿಂಗ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಟು ಗೋ ಹೋಮ್, ಹಾಸ್ಟೆಲ್ ಎಲ್ಲ ಖಾಲಿ ಮಾಡಿ ಅಂತ. ಸೊ ವಿ ರೆಕಮೆಂಡೆಡ್ ದೆಮ್ ಹೌ ಟು ಹಾರ್ವೆಸ್ಟ್ ವಾಟರ್ and how to store water and how to reuse that water anta, how to also reuse the treated water. So we have recommended them and they are implementing it actually. So actually it is helping. So Surat Kallal hog nodidre neevu, we have told them how to harvest water and implement it. If there are specific issues, we have technologies to implement these things. We will be happy to help. Please write to us. We are happy to help.
Sure. Thank you, sir.
If there are any other one or two questions, I'll be happy to answer. Yeah. Christy to Sanyal. Go ahead.
So thank you for the insightful discussion. So I am basically from social science background, to be precise, economics. Now, one thing is that all these kind of initiatives, so the benefits that are, possibly can be attained or obtained from those kind of initiatives. So that benefits are a future one. So now when it comes to have the initiative right now to bear some cost or bear some physical thing, many a times the community, they don't really feel the need or they don't have any ready-made incentive so that they can opt for bearing those costs or bearing those things. Now, have you considered that how any thought on your side that how to integrate that community so that there will be some autonomous incentive on their part that they can feel in working in line with that initiatives?
Yeah, no, we have done a cost-benefit analysis of this project. This project also has generated nearly 10-15 high-impact factor journal publications. All of that are published in journals, predominantly in Science of Total Environment. We have also looked at cost-benefit analysis of this project. So the benefit-to-cost ratio, even if we consider just the intangible cost, like higher tax collection because of higher productivity, higher price of land because of more water availability. So only the intangible cost, if we can collect as well, not the direct revenues going into farmer, but the direct revenues coming into the government, more fisheries, more milk, more livestock, more sericulture. If we consider all of that, the benefit to cost ratio for this project is 4. So for every rupee spent, government is recovering 4 rupees in addition to the goodwill that they have brought back livelihood to these people. So that is what we have done. Initially, there was a lot of resistance that we don't want this water, the water quality is not good. But now the situation has been reversed. They are stealing this water. So the primary concept of this project is have your water in the recharge tanks, let the water recharge groundwater, and you pick up groundwater and use it for your needs, either agriculture, industrial, or domestic need, so that we have the safety net of slow sand filtration coming in because of different layers of Mother Earth. But right now, people are stealing water from these reservoirs. So there is a lot of effort being put to avoid stealing of it. So there is a lot of buy-in from the community. And for the government, the benefit to cost ratio is 4, as against other projects where the cost to benefit or the benefit to cost ratios are less than 1.
Professor, this is Professor Manjappa. Can I?
Yes, sir.
Yes, maybe one last question and then I need to go for another meeting. If there are questions,
this is Professor
my
Manjappa.
email ID can be obtained by KSCST people. It's a simple narayana@isc.ac.in. You write to me, I'll be happy to answer. But go ahead, sir. Last question.
Yes, sir. This is Professor Manjappa. Can I have a question, sir?
Yes, sir. Please go ahead.
Sir, I was just delighted to see your presentation. It was a very good presentation. Only thing is, I have certain doubts. See, Bangalore, most of the high-rise buildings and multi-story buildings have been provided with STP.
Yes.
They have been asked to recycle.
Yes.
When I look at the calculations of the wastewater generation, most of the wastewater generated, you are giving at the almost more than 60% of the wastewater generation you are giving. Is it the correct calculation, sir? If I look at that,
numbers these are numbers measured. So we have measured the wastewater coming out. So what has happened with STPs? See, not high-rise STPs are not given STPs. They are asked to have STPs. They are mandated to have STPs and reuse the water.
Correct.
How do they reuse so much water, sir? Right. Today, they although by mandate they are supposed to reuse the water, they don't know what to do with that excess. So
you mean to say that mandate what is given by the government, they are not practicing?
No, they are practicing in terms of treatment, but they are not practicing in terms of, not all of them know what to do with their STP treatment. So the STP is always given the last, priority in the apartment complexes. So in the last summer, our team might have visited some 100 apartment complexes in Bangalore. Out of them, we only found 1 apartment complex who are treating to the highest quality. The rest 99 of them is an eye wash. So it is there in the basement, it works, sometimes it works, most of the time it never works. It is operated by some high school dropout kind of a person, and it's not doing the job at all. What do they do with this water? They push it into the Nala, which is close by. So that is the reality of Bangalore. And we have been telling them that they should basically avoid such things and improve it, which has not happened, but hopefully one day it will happen. So,
sir, when it goes to the Nala, see, there are controversies then. If it goes to the nearby Nala and then accumulates, how it will be a wastewater generation quantity is added to that. That is also a point. Measurement, how it has happened.
I will explain to you, sir. We have measured it at multiple locations. So we will share you the data. Come down when you have some
that's
time.
all right, sir. At this juncture, I also know that they will not be performing well, and they send it to the places where they can easily send out the wastewater generated by them. That's one point.
Yes.
The second point is, sir, most of the wastewater, even in Rushbat Rally, many scientists were worked, even the scientists and the medical doctors who have worked on the the crops generated, and there was also a report earlier. And halali milk allu sa lead bandbidide anteli, there was a report which was reported.
ಎಲ್ಲ ಹೇಳ್ತಾರೆ ನಾವು ಟೆಸ್ಟ್ ಮಾಡಿದ್ರೆ ನಮ್ಗೇನು ಬಂದಿಲ್ಲ ಸರ್.
ಅಲ್ಲ, there are scientists who have also worked ಅದು important medical college. There they are told lead is reported, nickel is reported, copper is reported in the wastewater and all. Now you say that
ಹೌದು ಸರ್.
in this wastewater treated there is no heavy water at all, heavy metals at all.
ನಮಗ್ ಸಿಕ್ಕಿಲ್ಲ
There are
ಸರ್.
two
ನಾವು
schools
6
of thought.
ವರ್ಷದಿಂದ ಹುಡುಕ್ತಾ ಇದೀವಿ.
ಅಲ್ಲ ಈಗ ಏನಾಗುತ್ತೆ ಸರ್ ಅಂದ್ರೆ ಜನರೇಷನ್ ಅಲ್ಲಿ ವೇಸ್ಟ್ ವಾಟರ್ ಅಲ್ಲಿ ಎಸ್ಪೆಷಲಿ ಸೀವೇಜ್ ವಾಟರ್ ಅಲ್ಲಿ ಸೀವೇಜ್ ಅಲೋನ್ ವಿಲ್ ನಾಟ್ ಕಮ್. ದೇರ್ ಆರ್ ಇಂಡಸ್ಟ್ರೀಸ್ ವಿಚ್ ಆರ್ ಲೊಕೇಟೆಡ್ ಇನ್ ಬಿಟ್ವೀನ್ ಆಲ್ಸೋ ಇನ್ ದ ಸಿಟಿ. ಅದು ಬಂದದ್ದು ಎಲ್ಲಿ ಹೋಗುತ್ತೆ ಸರ್? ನಾವು ಯು ಅಡ್ವೈಸ್ ಟು ಗೋ ಟು
ಪ್ರೆಸಿಪಿಟೇಟ್
ಕೋಲಾರ ಕೊಡ್ತಾ ಇದ್ದೀರಾ,
ಕೆಮಿಸ್ಟ್ರಿ ನಾವು ಒಂದು ಪೇಪರ್ ಬರ್ದಿದೀವಿ. ಅಲ್ಲ, ನಾವು ಪೇಪರ್ ಬರ್ದಿದೀವಿ, ಕರೆಂಟ್ ಸೈನ್ಸ್ ಅನ್ನೋ ಜರ್ನಲ್ ಅಲ್ಲಿ ಪಬ್ಲಿಷ್ ಮಾಡಿದೀವಿ. ಯಾಕೆ ಹೆವಿ ಮೆಟಲ್ ಬಂದ್ರೂ ಸಹ ಯಾಕೆ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗುತ್ತೆ, ಯಾಕೆ ನೀರಲ್ಲಿ ಇರಲ್ಲ, ಅದು ಸ್ಲಡ್ಜ್ ಹೋಗುತ್ತೆ, ಥರ್ಮೋಡೈನಮಿಕಲಿ ಹೆಂಗಾಗತ್ತೆ ಅಂತ ತೋರಿಸಿದೀವಿ. ಅದು ನಮ್ದೊಂದೇ ಅಲ್ಲ, ನಾವು ಇಡೀ ಪ್ರಪಂಚದಲ್ಲಿ ಒಪ್ಪಿರೋದನ್ನ ನಾವು ತೋರಿಸಿದೀವಿ. ಇದು ಎಲ್ಲ ಭೂತ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತಾರೆ ಸರ್. ಹೆವಿ ಮೆಟಲ್ ಅನ್ನೋದು ಒಂದು ಭೂತ, ಅದನ್ನ ಕ್ರಿಯೇಟ್ ಮಾಡಿ ಬಿಡ್ತಾರೆ. ನಮ್ಮ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ 6 ವರ್ಷದಿಂದ ನಾನು ಹೆವಿ ಮೆಟಲ್ಗೋಸ್ಕರ ಹುಡುಕ್ತಾ ಇದ್ದೀನಿ ನೀರಲ್ಲಿ. ಇದುವರೆ ತನಕ ನನಗೆ ಸಿಕ್ಕಿಲ್ಲ. ಅದು ಡೇಟಾ ಇದೆ, ನಾವು ಡೇಟಾ ಕೋರ್ಟ್ ಸಹ ಕೊಟ್ಟಿದ್ದೀವಿ. ಸೊ ನೀವು ನೋಡಿ ಪೇಪರ್ ಅಲ್ಲಿ ಸಹ.
ಅದ್ರ ಜೊತೆಗೆ ಸರ್ ದೇರ್ ಆರ್ ಆಲ್ಸೋ 2 schools of thought. ಈ ಮೈಕ್ರೋಬಿಯಲ್ ಕಂಟಾಮಿನೇಷನ್ ಇಂದ ಫ್ಲವರ್ ಬೇಗ ಹಾಳಾಗ್ತಾ ಇದಾವೆ, ಟೊಮೆಟೊ ಬೇಗ ಹಾಳಾಗ್ತಾ ಇದೆ. ಇದೆಲ್ಲ ರಿಪೋರ್ಟ್ ಬರ್ತಾ ಇದೆ. ದಟ್ ವಿಚ್ ವಿ ಆರ್ ಆಲ್ಸೋ ಲುಕಿಂಗ್ ಇಟ್.
ಹೇಳಿದ್ದಾರೆ, ಹೈ ಲೆವೆಲ್ ಕಮಿಟಿ ಮಾಡಿದ್ರು ಕರ್ನಾಟಕ ಗವರ್ಮೆಂಟ್ ಏನೆ, ನಾವು ಹೋಗಿದ್ವಿ. ಎಲ್ಲಾ ಹೇಳ್ತಾರೆ, ಡೇಟಾ ಕೇಳಿದ್ರೆ ಯಾರು ಕೊಡಲ್ಲ. ನೀವು ಕೊಡಿ ಸರ್ ಡೇಟಾ, ನೀವು ಹೋಗಿ ಮೆಷರ್ ಮಾಡಿದ ಡೇಟಾ ಕೊಡಿ ಅಂತ ಕೇಳ್ತೀವಿ ನಾವು. ಸಿ ಸೈನ್ಸ್ ವರ್ಕ್ಸ್ ಆನ್ ಡೇಟಾ. ನಮ್ಗೇನು ಡೇಟಾ ಕೊಟ್ಟಿಲ್ಲ. ನಾವು ಹೋಗಿ ಟೆಸ್ಟ್ ಮಾಡಿದಾಗ ನಮಗೇನು ಸಿಗಲ್ಲ. ಅದು ವಿ ವರ್ಕ್ ವಿತ್ ಸೈಂಟಿಸ್ಟ್ ಫ್ರಮ್ GKBK. ನಮ್ಗೆ ಏನ್ ಗೊತ್ತಿದೆ ನಾವು ಮಾಡ್ತೀವಿ, ನಮ್ಗೆ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ನಾವು ಎಕ್ಸ್ಪರ್ಟ್ ಅನ್ನು ಕರ್ಕೊಂಡ್ಬಂದು ಅವ್ರ ಜೊತೆ ಕೆಲಸ ಮಾಡಿಸ್ತೀವಿ. ನಾವು GKBK ಸೈಂಟಿಸ್ಟ್ ಜೊತೆ ಕೆಲಸ ಮಾಡಿದೀವಿ, ನಾವು ಕೆಲಸ ಮಾಡಿದೀವಿ, ನಮ್ಗೇನು ಸಿಕ್ಕಿಲ್ಲ ಸರ್ ಆ ತರ ಡೇಟಾ.
ಅಲ್ಲ, ವಿತ್ ಆಲ್ ದಿಸ್ ಒಂದೇ ಒಂದು ಕರೆಕ್ಷನ್ ಅಂತಂದ್ರೆ, ಈ ರೈನ್ ವಾಟರ್ ಹಾರ್ವೆಸ್ಟಿಂಗ್ ಗೆ ರೂಲ್ ಮಾಡಿರೋದು KSPCB ಅಲ್ಲ ಸರ್, ದೇ ಆರ್ ಆನ್ ದಿ ಮಾನಿಟರಿಂಗ್ ಏಜೆನ್ಸೀಸ್. ಅರ್ಬನ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಆಫ್ ಅರ್ಬನ್ ಗವರ್ಮೆಂಟ್ ಆಫ್ ಕರ್ನಾಟಕ ಹ್ಯಾಸ್ ಮೇಡ್ ದಿ ಕಾನೂನು. ಸ್ವಲ್ಪ ಕಮ್ಯುನಿಕೇಶನ್ ರೂಲ್ ಮಾಡಿರೋದು ಅಂತ ಹೇಳಿದ್ರಿ. ರೂಲ್ ಮಾಡಿರೋರು ಅರ್ಬನ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್
BWSSB ನವರು ನಿಮ್ಗೆ ವಾಟರ್ ಕನೆಕ್ಷನ್ ಕೊಡ್ಬೇಕಂದ್ರೆ ಅದು ರೈನ್ ವಾಟರ್ ಹಾರ್ವೆಸ್ಟಿಂಗ್ ಇದ್ರೆ ಮಾತ್ರ ಕೊಡ್ತಾರೆ ಅಂತ ಹೇಳಿದೆ ನಾನು.
ಅಲ್ಲ, KSPCB ಅಂತ ಹೇಳಿದ್ರಿ, ಬಟ್ ಅರ್ಬನ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಕಾನೂನು ಮಾಡಿರೋದು ಸರ್ ಇದು. ದೇ ಓನ್ಲಿ ಫಾಲೋ. ಇವೆರಡು ಮಾನಿಟರಿಂಗ್ ಏಜೆನ್ಸೀಸ್ ಇದಾವಲ್ಲ ಸರ್, ದೇ ಫಾಲೋ ಇಟ್. ಇಟ್ ಓನ್ಲಿ ಫಾರ್ ದಿ ಜನರಲ್ ಪಬ್ಲಿಕ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಅಷ್ಟೇ.
ಸರಿ ಸರ್. ಬೆಂಗಳೂರಲ್ಲಿ ರೈನ್ ವಾಟರ್ ಹಾರ್ವೆಸ್ಟಿಂಗ್ ಇದೆ ಅಂತ ಹೇಳೋದು ನನ್ನ ಉದ್ದೇಶ ಆಗಿತ್ತು.
ಹೌದು, ಅದು ಹೇಳುವಾಗ ಕರೆಕ್ಟ್. ಬಹುಶಃ ಅದು ಇದೆ ಮಿಸ್ನಾಮರ್ ಆಗಿರ್ಬೋದು. ಅರ್ಬನ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಕಾನೂನು ಮಾಡಿರೋದು ಸರ್ ಅದನ್ನ.
I think we can take...
That was only the information which I just wanted to communicate. Okay, sir. Please carry on. Please carry on. Okay.
Yeah. Thank you very much.
Thank you all of you. If there are more questions, I'm always there in IISc. You can reach me. My email IDs are available with the Karnataka State. My website has it. KSCST has it. So please write to me. Whatever information I have, I'm happy to provide. So with this, I thank all of you for patient listening. I thank KSCST for giving me this opportunity and sharing our experience on these projects. Thanks a lot. See you. Bye. I need to run for another meeting. Thank you. Thank you.
Now I would like to invite Professor Bhupendranath Goswami, Honorary Professor of Science, Goa University, to take over the sessions. Over to you, sir.
Thank you very much. May I share my screen?
Yes, sir.
Okay, let me try to share my screen first. How should you share that? How do I share this entire screen? Yeah.
Entire screen, you have to select entire screen.
Entire screen and select share. Okay.
Yeah, it has shared, sir.
Can you share? Okay. Can you see again?
You can maximize your PPT, sir.
Okay. 1 minute.
You are visible.
Okay.
Screen is visible. You have to maximize.
Screen is visible. Okay. So now I'm going to. Is it full screen mode? Can you see it?
No, not yet, sir. You have to bring PPT. Presentation is not visible.
Presentation is. Sorry, that means something wrong.
So you can just unshare and then again.
Yeah. Yeah, let me.
Share screen while sharing. Yeah, now it is. Yeah, just maximize PPT.
No, it's just.
No, something is wrong because something is, I go to maximize this. 1 minute, I'll do just before I'll maximize it and I'll keep it there. Oh no, I'm sorry, 1 minute. Okay, let me unshare it and again share it again. How do I
Sharing.
stop sharing?
Yeah, again share and select entire screen.
Yes. Okay, so select entire screen. Okay, I select entire screen.
And then go to a PowerPoint presentation.
No,
Govindranath sir,
no.
you can click on the share button, the up arrow. In that you can see the third icon, entire screen.
Right. So I clicked entire
on
screen.
that.
Then I click on this
Share.
Share.
no, the share thing is not coming up. So I click on this entire screen. Now share button is coming up. Or the share is coming up. So I click on it. Then
Let's select share.
We can able to see your screen. Go to PPT. Open the PPT, PowerPoint presentation.
Yes, this is the PPT. Now PPT, I am going to open the. I'm going for PowerPoint.
Maximize PowerPoint.
Maximize. Can you see it? I have gone for full screen, but
Now you can open the PowerPoint.
Yeah, it is open. What is? Can you see it now? No, I can see it in my end, but there's still some issue. What is it? I don't know what is.
Email the PPT. We can project it from here. That's also possible.
Is it possible from your side to open?
Email.
Just share it within this thing only.
It is maximized. It is full screen mode. It is coming up here. Is it changing on your side?
No, not yet, sir.
No, it is not changing. No, that is not correct. So something is wrong with it.
KSCST.info.
Sir, you can see the email ID in the text box, chat box, sir. So can you share your PowerPoint presentation to this email ID?
Okay. Can I send it to email ID?
Yeah, that's good. That's better.
Okay.
You can operate.
Okay. 1 minute. 1 second. Let me. So this email, I'll just 1 minute. I'll send it to you in a minute. One minute, let me. Okay. Sorry about this. I don't know, some technical issues here. 1 second. Okay. So it is sent. Can you check it?
Yeah, we will check it, sir.
Can you check it? It would have been better from my side because operating some of the somebody else have to operate it from that side. It'll be a bit of an issue. But anyway, let us see.
Inbox is different. Today, that's it.
Sir, on your screen, there is something like mid of the screen, show my screen anyway. Can you click on that once?
Which one?
Yeah, click on that. Yeah, show.
Show my screen anyway.
Show my screen.
Uh,
Show my screen. Okay.
Now you go to PPT, sir.
Now I go
PowerPoint.
to PPT. Okay. Yeah. Now, is it coming? Full screen?
We can able to see your screen, but not PowerPoint.
Not PowerPoint.
Panel.
Can you open it? Open my PPT in your end?
No, your email has not yet received, sir.
Oh, you're not received. So it's about some 29 MB. Should I?
It is sent to studio@ksst.info.
Yeah, that is the case. From where I sent it to Office KSCST. Office KSCST. Is it?
1 minute. Yes. Okay, sir, we will receive it.
Okay. I don't understand now. I do so many of these online meetings, but why it is not working? Shall I stop sharing from my side? Hello.
There is a PowerPoint icon on the bottom. If you can click on that, it would probably show. There is a PowerPoint icon at the bottom.
Bottom.
Go down. Yeah, go more. Yeah, there are 2 PowerPoint icons. One of them has to be not the Word document. That one is a PowerPoint.
Yeah.
Now you can click on the slideshow mode, sir. Slideshow.
No, wait.
So now at the bottom you see
Or
at the
press
bottom
F5.
at the bottom you see comments, and then you see above. Take your cursor above.
Yeah.
Come more to the right. You will see. Yeah, come further to the right.
This.
Come further to the next.
Right.
Yeah, click on that.
Open that.
Same one.
Yeah.
Yeah, but this is my this is another presentation, but
So like that, there would be another. So you you can so you go down. There is another PPT there. There is another PPT. 1, 2, 3, 4, 5 down. Go to the 5th one down from this PPT.
Okay, 1 second. How do I go down?
You take your cursor. Take your cursor. Your cursor is on the PPT now. Take your cursor down.
Yeah. Okay.
Go to the right. Go to the right. Absolutely right. Yeah. Now here. No, down. Next level. Yeah, here. Go down further. Zoom. Then there is another one, and that next one there is a PPT. Is that one climate change mitigation, Miraj?
Right. I got it. Okay. Now I click. Now it is visible in your place.
Yeah, it is visible. Click
Now
on it.
Presentation, yes.
Is it okay?
Yeah.
That's right.
That's coming.
Yes.
Correct.
Okay, great, wonderful. All right. I'm sorry how much time we wasted. Okay, thank you very much for. Is it the changing? Is it changing the slides?
Yes,
Yeah,
sir.
it
Yes,
is changing.
Okay, thank you.
Yeah, good.
Okay, thank you very much for inviting me for this your Golden Jubilee celebration, and I'm happy to talk about this climate. This is actually a slightly different PPT. This is not the one that I wanted to present, but sorry. Okay, I think this is what I prepared is lost somewhere, but this is slightly different. But I think we'll do it this. But today I wanted to talk about slightly. The title was that the climate change, your climate change and sustainable development, and my talk will be essentially around basically for on a larger aspect, bigger issues of the global climate. You have just listened to the earlier talk on very local issues of sustainability, but the global sustainable development on a larger scale is associated with the global climate change, and therefore the climate change is intimately related to the sustainable development, and therefore if we have to actually achieve sustainable development, we have to solve the problem of climate change. And there are actually basically so we have been always talking, so everybody in the world today is talking about sustainable development. We need sustainable development. The sustainable development is required because the climate change has made it necessary for development to be sustainable. Now, therefore, but we are always we are not doing all that is required to do sustainable development to solve the climate change problem, and as a result we are unable to really achieve climate change sustainable development. And over the last several years, all the sustainable development goals set up by the United Nations Sustainable Development Goals over the last couple of years, we have assessment has shown that we have not achieved even one of them, and we have not even come close to that. So the point is, this is because of the development model that we are following, and we need to change that. And so therefore, there are actually two narratives that are going around. One narrative is very optimistic narrative that over optimistic narrative that says that okay, we can solve the climate change the sustainable climate change problem, or we can do sustainable development because we can do a lot of innovations for green energy generation as well as decarbonization, and therefore we should be able to continue to use energy as we please, and therefore everything will be okay, and the onus will be on the sort of the onus is essentially shifted towards the general public. Instead of people who are responsible for producing creating the problem. So that is one kind of narrative which tends to shift the blame on all of us instead of who actually created those problems, especially in developing and least developed countries. On the other hand, the other narrative is, of course, is essentially the scientists are saying that we are actually we are reaching a stage which is kind of there will be what you call there can be disasters which essentially we are leading towards towards 6 mass extinction, and therefore it is very very pessimistic, very serious narrative, and that is essentially is a kind of other end. But I think we need to think about a sort of my take in this is that we must think about something in the middle ground where the sustainable development is possibly possible, but we have to change the development models that we are following. And so this is what I am going to sort of talk about in this. First, let me talk about what is the problem. The problem is essentially the sustainable development is essentially related to the climate change. And the climate change, this is a picture that actually tells you what is the climate change problem. The climate change problem, this is, sorry, the climate change problem is essentially associated with this temperature increase in global mean temperature increase. This is the record of last 2,000 years of global mean temperature, and as you see, I'm sorry, this change in this PPT has really caused a mess. I'm sorry, but okay. So the first
from our end.
Can
we share the PPT from our end?
Yeah, can you do that? Is it possible now?
Okay, sir. You can.
Please do that. I'm really. This is.
Please stop sharing from your side, sir.
Okay. Okay. Sorry.
Thank you. We will start from here now.
Okay. That will be great. Yeah, because I organized the material in a slightly different way.
Yeah.
Okay. That's great. Okay, can you go back? So start from the beginning first. Okay. And now can you? You have to. So go next. Okay. Next. Okay. So this is the temperature. Go to the. So this is the temperature. So the problem is essentially, what is the climate change problem? The climate change problem is the rapid increase of global mean temperature in the recent 150 years or so. So if you take this record, this is 2,000 years of record of global mean temperature. This was actually published sometimes in 1998, and this made a big news because this is based on, you see, the global mean temperature, instrumental record is only for about 150 to 200 years, right? But we can reconstruct the temperature, global mean temperature, by using certain proxies in the past, by using free rings and various other chemical proxies which depend on temperature. And from that, we can create a global mean temperature estimate. And there are different proxies, but each proxy is slightly different, has different uncertainties. So if you take a large number of different proxies and create a multi-proxy ensemble mean, that gives a good estimate of the mean temperature and its variations. So over the 2,000 years, you see the temperature has, this is with respect to the pre-industrial condition. And with respect to the pre-industrial temperature, the temperature has remained more or less slightly above pre-industrial for the last almost more than 1,500 years. And there are about 200 years ago, 300 years ago, there around 1600, 1700, there was something called a little ice age. So the mean temperature decreased by about 0.3 degrees, 0.2 degrees. And then suddenly, from pre-industrial to about the industrial period, it started increasing very rapidly. And that change, this increase within 150 years is about 1.5 degrees today. Whereas these variations over the 2,000 years, the year-to-year variations or decade-to-decade variations are of the order of 0.1 and 0.2. So that means that is why we call it a climate change, not climate variability. The natural variability is of the order of 0.1, 0.2 degrees global mean temperature change, but in the recent 150 years, we have changed it within a very short time, more than 1.5 degrees, which is very large compared to any changes that we have recorded in the past for many years. This is 2,000 years record. Now we can see that over 1 million years record also, we have not seen this kind of a change over a very short period of time. That is why this is climate change. And this large change has lot of impact. And that is what is making. And these happen to be associated in this region. This period happened to be the Industrial Revolution period. So when Michael Mann published this paper, he actually indicated that, okay, the climate change problem may be related to these industrial development, and that created lot of hue and cry, and lot of people who were these oil lobby people, etc., insinuated that he has manipulated data and everything, and therefore there was a huge debate, and that debate took him, actually he went to the court. And those people actually insinuated that he manipulated data and all that. So he went to the court, and that court, the fight was going on over the last 25 years. And finally, in the last 3 months or so, he was awarded more than $1 million compensation from those people who alleged him. So this is, and over this period, lot of studies have compared the data and found out that these are all established that the data is correct, and this change is based on observations and reliable observation. This is the correct change. So therefore, the problem is well established, and there is no next. Can you go to next, please? Next. So this the next is, as I said, there are these two or three over. Can you go quickly? So there are 2 or 3 different. So one is an over-optimistic narrative, which says that okay, we can solve this problem by using green energy generation and decarbonization, but it requires a lot of new innovations and investment and money, which we are not doing, and therefore, but then still they continue to go on using the energy. So on the other hand, the doomsday kind of narrative is that we have actually crossed the safe and just tipping points of the climate because of these changes in the environment and their effect. And once it changes these tipping points, then the climate may never be able to come back to the original climate, and as a result, there will be potentially disastrous effect. And but other thing, I think what I am going to do today is essentially trying to show that the first the evidence does not support the over optimistic narrative, but we need to consider. And there is a lot of hypocrisy about the way the over optimistic narrative is carried on, and then I will suggest some possible on my common sense way. I will suggest that some possible way of potentially possible pragmatic potential possible sustainable development pathway. Next. So there are different. We know now that what causes, what are the drivers of climate change, what are these possible impacts, and what needs for mitigation, and what we need to do for adaptation to this climate change. And this is all known, but we are not really doing what we need to do to do this mitigation and adaptation, and that is the main problem. Next. So can you go next, please? So the science is well established, and because this was done all the way back in 1967, when the simple theories and models have established that if we double the carbon dioxide, how much the temperature, global mean temperature should increase. And there is, of course, it is not there is always be some uncertainty because the whole climate system is very non-linear, very complex, and as a result, there will be some uncertainty. But we know the bound of the uncertainty. And then therefore that we have to take the decisions based on this uncertainty. We keep taking decisions based on all uncertainty in many things, but when it comes to climate change and its impact and this sustainable development, we don't take those decisions, and we try to find out faults about this, and this is the hypocrisy actually. So this is well established, and recently because of this work, Professor Manabe, and then in 1979, Jules Charny chaired the committee who reviewed all the work and the data and came up with more or less the same range of increase of global mean temperature as a result of carbon dioxide. And so therefore, so this thing was done all the way in 70s, early 70s, it was well established, but we have not been taking any decisions. And today, even today, when the situation has become so bad, even today we are not doing decisions. So so as a result, in 2021, Professor Manabe was awarded Nobel Prize in Physics. So physics people also think that the science is solid today. There are times when physics people did not think that the science of climate change was well established. But today I think there is no doubt about that. Next. So to understand the problem, I think let me just say we have to understand a few things. We must recognize that the art's environment is art and this environment is very unique in the whole universe. I think all of us know, but you don't know that the very unique combination of its constituents and the distance from the sun, the size of the planet, and all that has made our climate the way it is. It is something called a Goldilocks climate. It is not too hot, not too warm, where all the three states of the water vapor can remain exist, and as a result, it can sustain life. But it has happened, but this climate did not happen overnight. It happened through over a 4.6 billion years of evolution. The climate was very different in different times of evolution of the Earth, but it happened only over the last few million years. The climate became as good as for life to exist and flourish. And but the next step, next. But when the humans have the human history, intelligent human history is only about 12,000 years old. And during this small part of the evolution of the Earth, we have destroyed the environment so much so that now we are facing something called the sixth mass extinction. Next. The end Earth climate is essentially a energy balance problem. So this sun's energy, drives the energy, heat energy into the Earth, and that heat energy is essentially the energy balance gives rise to the mean temperature. Mean temperature is a representation of the climate. Now this heat balance can be affected by the environment, and therefore modified by the environment, and that is therefore the environment can interact with the climate. The temperature will affect the environment. Environment consists of the atmosphere, cryosphere, biosphere, and hydrosphere, and these things can temperature affects them, but they can also affect the temperature through the participation of the heat balance. And as a result, these two environment and the climate are all the time interacting with each other. And therefore, we have to be very careful about not changing the environment in a substantive manner. So next, so there is example of next. There is a good example of how the environment has and the climate has been interacting over the last million years. For example, this is a record of temperature, carbon dioxide, and methane is extracted from the ice core in the Antarctica. Now we have gone and dug ice core from the Antarctica up to about 4 kilometer depth, and from that ice core we can find out different air bubbles inside those ice cores can give us the concentration of carbon dioxide. We can date them. From the date, we know what time it happened, and then how much carbon dioxide and methane was there in the atmosphere. And also from deuterium isotope, we can find how much cloud, what was the kind of ice volume. And ice volume is proportional to temperature, and therefore we can get a temperature record also. So there is a temperature record. One of them is temperature. This is a temperature record, and this is a 800,000 years record. Okay. So this data comes from this resolution is a little slow because they are low, and therefore, and And these temperatures, again, with respect to our pre-industrial reference point, if you plot these temperatures, you have these large positive and negative fluctuations of temperature. These are known as the ice ages and warm periods. Today we are in the warm period. Warm period is called interglacials. So we are in the interglacial period, and that is where life is good. But then you can go to so there are warm periods in the past, about 100,000 years apart. There are warm periods, and then you go to ice ages, and again you come for a warm period. Warm periods are shorter, about maybe 20,000 years, but then again you go to about 30,000 years. About 70,000 years you go to a cold period. So this oscillation is known as glacial interglacial oscillation. These glacial interglacial oscillations are very large changes in the climate, and that large changes in the climates are very coherently happening with carbon dioxide and methane also. So this carbon dioxide and methane is changing in the atmosphere. That affects the temperature. The temperature changes in the atmosphere again affects releases more carbon dioxide, and then more carbon dioxide affects the temperature, and that again releases more. So there are feedbacks that is possible by changes of carbon dioxide, for example. This is a simplistic view, but there are a little more complicated feedback. But this feedback can change the carbon dioxide, or it can start with the changes in the carbon dioxide or methane, and that can change in the temperature. That can change the carbon dioxide again, and that can change the temperature again, and that feedback can lead from a cold phase to the warm phase, or again from warm phase to the cold phase, and this oscillation can go on. This feedback is very important, and it can feedback can give rise to this kind of a large oscillation. So this is a clear indication of how environment and the climate keep interacting with each other and produces variability in the climate. But today, what has happened is we have gone beyond. We are sort of gone to a regime that is what we call tipping point, and so we are going beyond the tipping point where this kind of an interaction may not be possible. The feedback may not be possible to bring the temperature down to a colder phase anymore, and that is the tipping point. Okay, next. So this happens because of this. To understand this, also we have to understand the carbon balance in the atmosphere. So how you are changing the carbon balance in the atmosphere? So, for example, if in the industries and other things and vehicles and all emitting certain carbon dioxide into the atmosphere, and then they are absorbed by vegetation, then they are absorbed by the ocean, and the ocean also release certain, and the land also release some carbon dioxide. So all these, there is a feedback. There is a emission. A part of this emission then gets absorbed in the vegetation and in the ocean, but a part remains. So it turns out that through all this absorption and emission of carbon dioxide, if 100 units of 100 tons of, let us say 100 tons of carbon dioxide into the atmosphere, about 50% remains in the atmosphere. About 50 gets absorbed in the ocean and vegetation and so on. So this is a very simple balance. So that means that if we keep on producing more and more carbon dioxide emissions into the atmosphere, every time suppose I have 2 gigatons I am emitting, that 2 gigatons, 1 gigaton will always remain in the atmosphere. Then again next year again I use 2 gigaton or more, just half of that will remain. It will build up, and that is what has happened over the last 150 years due to industrial revolution. We have added almost. Let me show next, please. And that has happened because over the last. This is the kind of history of sort of how much carbon we are putting into the atmosphere due to the emissions. So in 1991, for example, we had about 2 gigatons of carbon dioxide emissions were there. Out of this 2 gigaton, 1 gigaton remained in the atmosphere. Like that, it went and went. And today we are here. Today in 2024 we have emitted 41.6 gigaton carbon dioxide in the atmosphere, carbon in the atmosphere. And out of that, 20 plus is still remaining in the atmosphere. So that is how we are building it up. And these are different countries' contribution and so on. So I don't want to spend too much time, but important point. And can you go to the next, please? So this is the US contribution. You can see that it started all the way before 1901 and then continued in a very large. And this is China. China started only, all the Asian countries started, developing countries started only from about 1950. But whereas the developed countries like North America and Europe, next. Can you go back now? In Europe, for example, they started from a long time ago. So their contribution, cumulative contribution, has put a lot more carbon dioxide in the atmosphere, which remains there. And carbon dioxide is a very inert gas, and it remains in the atmosphere for more than 200, 300 years. Can you go back to the two slides, please? Next, one more. No, back. Stop here. So the point is that with this process, we had currently there are about 2,500 gigatons of carbon dioxide in the atmosphere. In 1901, it was like 1,500. Over the last 100 years, 120 years, we have added more than 1,000 gigatons of carbon dioxide in the atmosphere. So to solve the problem, you not only have to cut down this, but this will remain there for next 300 years, and therefore they will continue to heat the atmosphere unless to solve the problem. Not only we have to cut down emission, so the cutting down emission becomes so much more important that not only you have to cut down, we have to actually extract and remove it. How do we remove it? That removing the carbon dioxide from the atmosphere is a very difficult process. Next, please go ahead. Next. Just let us go through this quickly. So that is the next. Go down. Next. Just go through this. Next. Okay. So how did this problem started? The origin of the problem started with actually the population growth, and so this is a record of again 2,000 years of how carbon dioxide in the atmosphere and population changed or grew, carbon dioxide gross domestic product grew, and how fossil fuel emissions grew, and the carbon dioxide. So the fossil fuel emissions and carbon dioxide in the atmosphere are related because of that thing I'm saying, that carbon balance. Once you emit, a part of it remains in the atmosphere. So the growth of atmosphere is related to the emission. And that also is related to population. So when population also started increasing rapidly around 200 years ago, and then started exponentially increasing in the last few decades. And the carbon dioxide used to be like 280 parts per million for many years. When the little ice age, it went down a little bit, again through that interaction between the environment and the climate, and then again the industrial revolution, it exponentially increased. So there is empirical evidence. This is still not a conclusive evidence that this industrial revolution is definitely is responsible for this. And this is related to what the industrial revolution was always based on the GDP growth model. The growth and that GDP growth models requires energy intensive industries, and those energy industries require more and more energy, and the electricity that requires more emissions from fossil fuel generated electricity. Next. So how bad this problem is, you can see from this problem is bad. Again, by looking at paleoclimatic data, we can see how bad this problem is. This is a record of not just 2,000 years, but for about 5 million years of global temperature. How temperature changed in the global mean temperature changed over the last 500 million. About 65 million years ago, the temperature was about maybe 12, 13 degrees above the pre-industrial relationship, very warm. Of course, there is no life there. No human being. There is life, but not human being. And then temperature, the earth cooled slowly. Something happened. The full screen. I'm sorry. Can you It cooled, and then around 3 million years ago, it started coming closer to our pre-industrial temperatures, and that from that time onwards, this temperature has been relatively stable, and it has had these oscillations, these called glacial interglacial oscillations. These scales are very varying scales, and therefore expanded in the recent years. And in the recent years, we have gone through the little ices, and then now we have come back to we have above the pre-industrial is about 1.5 degrees, and in the coming years it is expected to go to about 2 to 3 degrees more. So, Khati, if you look at next, please. So if you look at what happened, that none of these, we are already today we are already at higher than any of the past interglacials. And if we go to 3 million years ago, that is when this stable climate started. Before that, the temperature, mean temperature was slightly warmer. When it was warmer than this, then these oscillations could not take place because of this because the feedbacks could not take it from the warm climate to the cold climate. And as a result, today, if we go beyond this, it is necessary to assume that we will not be able to come back again to this stable climate, and it will continue to increase. So therefore, that is the kind of tipping point. So if 2 degree is absolutely 2 degree increase above the pre-industrial, it may be absolute critical value. If you cross that maybe we may not be able to come back, because at that time again this also tells us then the more of the ice will melt, more positive ice albedo feedback will again increase the temperature, more permafrost will melt, and that will put more carbon dioxide in the atmosphere. So it will be very difficult to come back to this. It will continue to increase the global mean temperature, and it will be difficult to come back. This is something called runaway greenhouse effect. So there is a possibility of runaway greenhouse effect until we may never be able to come back, and that is the unsafe boundary to cross. So this is something called sustainable development requires certain boundaries not to cross, and this is one of the boundaries that we have almost crossed, and that is the problem. Next. So please go through this quickly. So next, I don't want to spend. So there is over the last few years, of course, alarming bells are ringing. There is no. I don't want to go into all what is happening in different. But I just go to next, please. I just want to mention one thing. What is happening next? So last year, the status of the climate, we can see that continuously over the last several years, every year it is more or less making a record. So that means, and it sort of seems like the trend is accelerating. In the last few years, you see the during these years, the number temperature increase trend was weak, and then recent from about 1960s it has started increasing fast, and in the recent few 20 years it seems to be increasing even faster. On the top of that, of course, the climate always have every year there is certain year-to-year variations and certain decadal variation. Sometimes it can come down a little bit, but it will still going up next year. But if you look at longer term trend, the trend seems to be increasing, and we are already in the atmosphere. We are now at 420 parts per million carbon dioxide. The methane is almost 2000 parts per billion. These are like about 50, 60%, 70% more than the pre-industrial time, and this is like 3 times more than the pre-industrial time. So this is a huge change in the greenhouse gases in the atmosphere, and that is non-trivial. Next. So the important thing that is happening, changes are happening. One of the important things that I see is very serious is that the global temperature, ocean temperatures are increasing. Of course, in global the air temperature, the land temperatures are increasing, but the ocean has large heat capacity. Once the ocean heat temperature increases, and over the last, if somebody had done, a lot of research papers have come out as how to establish and document how the global ocean temperature is increasing. If you take all the ocean parts and their global mean temperature, surface temperature, the top 200 meters of ocean contains the warm waters, and the top 200 meter ocean, the heat content has increased considerably, and that is related to also the surface temperature. For example, surface temperature has increased from about 17.5 degrees in 50s to about 18.8 degrees in 2024, 23. And 24 also it remains. Once it is increased, this heat content it will take long time to dissipate, and then this heat content increase in the ocean is causing fueling all the extreme events. Extreme rainfall events are increasing, their frequency is increasing, typhoons are becoming stronger, and that is going to continue. And because this is a major problem. So as higher temperature, ocean temperature is producing more evaporation. That evaporation is now remaining in the atmosphere because mean temperature has increased. The atmosphere can retain more moisture, so the atmosphere is becoming more humid. More humid atmosphere is causing heat stresses, increase in the heat stresses. More heat events have become increased. So all these things are going in that positive kind of positive feedback is increasing all these. Next. So the point is that this basically so this fact that the greenhouse, there has been a lot of debate about whether the greenhouse gases itself is producing the climate change, but I think there is enough science and evidence that there is no doubt that this is the most a prominent driver of the climate change, and this has been developed. This has been established by a large number of model experiments where we can show that if I simulate the climate with forcings without the greenhouse gases and with greenhouse gases, without the greenhouse gases, the temperature would remain more or less at the pre-industrial level, but if you add the greenhouse gases and continue to simulate the climate, and it shows that the recent increase in temperature is essentially due to the greenhouse gases. So this is another support to show that the industrial revolution and the greenhouse gases are the primary driver of this climate change. Next. So now there has been what I want to highlight is that the model of the industrial the sort of GDP model that we are following for the industrial revolution around the world is unsustainable, and that is increasing the inequity in the world, and there are a lot of studies now have shown that the most of the high income groups, whether it is individuals or in industries, they have contributed largely to the increase in the temperature. In the global mean temperature, their contribution is much larger than the contribution from the other people who have the low income group people. So there is considerable studies that have shown, and they have several published literature that provides data that shows this. Next. Okay. Can you go through this quickly? This because just go through this. So to understand this, we have to understand also how this greenhouse gases actually produces the heating in the atmosphere. For example, increase in the global mean temperature. Next, to do that, we can understand how the heat balance heat balance takes place in the atmosphere. Next. So this is essentially is result of the energy balance from the Earth. Solar energy is the main driver, and this energy comes into the atmosphere. But because of the atmosphere, a certain the solar energy comes in short wavelengths, and that energy does not get absorbed in the atmosphere because of the molecules in the atmosphere cannot absorb them because they are mostly nitrogen, hydrogen. But that then hits up the atmosphere, Earth. The Earth then acts like a black body and it radiates by its own. But its temperature, mean temperature, is lower. Therefore, it radiates at a longer wavelength. And these longer wavelengths, when they tries to go out and escape to the space, gets absorbed in the atmosphere by carbon dioxide, water vapor, and methane, and gases like that. And that means that not all the long wave radiation can escape to the space. As a result, you need to increase the temperature so that the energy that you receive from the sun is balanced by the energy that you lose to the space, and that is why the temperature increases. The equilibrium temperature has to increase if there is a greenhouse, if there are greenhouse gases in the atmosphere. Next, so how climate can change? The climate can change if these are drivers of the energy input, which is the solar energy, sun's energy. That changes. That has changed. And the solar energy can change due to the geometry of the Earth-Sun system, and that has three different kind of time scale in which it can change, about 100,000 years time scale because of the eccentricity of the Earth, and there is also a 40,000 years time scale, which is due to the inclination of the Earth on the ecliptic plane, and there is another 21,000 year time scale where the axis itself gyrates around this gyrates. So these variations can produce energy in variations received in the atmosphere, and that can change the temperature variation. But what we are seeing today, there is nothing like what your changes in the are not related to these, because these are very slow time scale. In the time scale that the temperature is changing, there is no forcing from the Earth. Next. So this balance, you can get this energy balance, the incoming solar radiation. If I balance with the outgoing long wave radiation from the Earth, I can get an equilibrium temperature. So these are controlled by three factors. One is a fraction of the solar radiation gets reflected back. That is called by the clouds, vegetation, ocean, etc. Everything reflects back a part of the solar radiation, and that reflection is called albedo. So that albedo is essentially if S naught is the amount of solar radiation comes in, about alpha a fraction is reflected back. That alpha fraction is about 30% today, averaged over the whole world. And then this follows what is called this is Stephen-Boltzmann. It follows the energy. Then the black body radiates following what is called Stephen-Boltzmann law. It as a function of T to the power 4. Its equilibrium temperature is T, it radiates at the rate of T to the power 4. And so, and it radiates all around the surface. So we can balance that. But then all the radiation does not escape. So there is a factor called infrared transmissivity, excuse me. So this infrared transmissivity depends on the constituents of the atmosphere. If there is no atmosphere at all, then everything will be lost. So if I put tau equal to 1, that means no atmosphere. And if I balance this, next, then if I put tau equal to 1 and balance it, I find the global mean temperature should be 255 degrees, that Kelvin. That is about minus 18 degrees Celsius. Okay, and that is what the temperature is at the top of the atmosphere, like about 20 kilometers or so. If you see that temperature is like that, because there is no, above that, there is no greenhouse gas. So that is what would have happened at the surface if I did not have an atmosphere. And that would have been disaster, because it will be cloud, all ice covered earth, and there will be no human, I suppose. So there is a natural greenhouse effect that is actually controls our this Goldilocks climate, and that is but that natural balance or natural greenhouse gas we are disturbing by adding that extra 50-60% carbon dioxide, extra three times more methane. All that is disturbing that environment, and that environment requires that the temperature of the atmosphere surface must increase further, more than that 280 degrees, and that is what is the anthropogenic greenhouse effect contribution, and that is what we are interested in. Next. Okay, next. I think this is the physics about the greenhouse effect. I think I may not have much time to do that. So most important thing is the sustainable development requires that the earth must remain within certain bound. The climate must remain within certain different aspects of the climate must remain under different bounds. One bound I mentioned is that the global mean temperature should not increase more than 2 degrees above the pre-industrial. The other bounds are like how much aerosol should be there, how much aerosol can be there, and how much their radiative effect can be tolerated, and how much biodiversity impact can be tolerated, and all that. There's something like several and 9 different parameters have been identified, and there are different boundaries have been established, and there are several studies and has shown that that 7 out of these globally safe, and these are called safe boundaries. Safe boundaries because if they cross, then we will go to a tipping point. Kind of, it cannot come back to that. That ecosystem may not recover, the temperature may not recover, and things like that. And then it will sort of become disastrous after that. So out of such 9 such parameters, 7 of the 8 globally safe and just Earth system boundaries, and at least 2 regional safe and just Earth system boundaries, over half of the global land area are already exceeded the limits. So that is what sort of assessment has been made by a group of climate scientists, social scientists, economists, and all together. A couple of very detailed papers have come out in the last couple of years. Next. So the main reason behind this main culprit is essentially the energy consumption. So you see that we have to understand why this is happening, and it is happening because the energy demand is increasing, and energy demand is associated with industrial revolution. 1950s, from 1950, if you see, until then the developing countries had not put anything, and after that. Developing countries also started putting, demanding more energy, because they said that they also need development for their growth and so on, and that is how it started increasing. But today we have out of total energy consumption, almost more than 80% is still fossil fuel based. That is the dirty energy. Only 20%, less than 20%, 70% is. That is a big problem. And you see that atmosphere already carbon dioxide 1,000 gigatons we have already put in, and we are not able to now decrease the emissions. If I cannot decrease the emission, then how will you ever be able to control the climate? It is impossible. So at this rate, if we continue, it is simply not possible to control the climate, and therefore it is. So main problem is that we need to produce more green energy, but we are not producing. And next. So what is required next? So what is required that we need to cut emissions. Emission must be cut, and we must cut today. Not it should have done yesterday, but instead we are in fact encouraging many countries like USA today has gone back to one thing. They have come out of Paris Agreement, and now they are, because the fossil fuel is cheap, to increase their profit, they are going to explore more green, more fossil fuel energy, and cut down all the green subsidies to green energy development. And that is what is. Instead, we need to put more development, more innovations, more investment in the green energy development. And that, instead of happening that, we are doing the reverse, where we are encouraging and going on using more and more fossil fuels and cutting down subsidies or encouragement into green energy development, and that is a very serious. Under this condition, I don't see we can have sustainable development globally. So investments are required for this innovation, but we are not able to generate that investment. Nobody is coming forward. Even the developed countries whose responsibilities should be this to support this, instead of that, they're using all kinds of arguments, smart accounting, to say that, well, we are doing this, we are doing that, and all that. But this is all. So the commitment is not there by most of the responsible people. Next. So the hypocrisy is that the sustainable development, we are undercutting this, like US has been undercutting the fossil fuel cost. Thus they promote fossil fuel consumption rather than putting. We have to actually deter using fossil fuel. They should put more taxes on the fossil fuel. Instead of that, they are promoting, subsidizing the fossil fuel use. Government is doing that. They invested almost $600 billion in subsidizing the fossil fuels in last year. So these are, I think, huge problems. Next. We have also, if you look at these are data that I have gathered for various different publications, that green energy developments around the globe has also gone down over the last. It was going up to about 2012, and since then it has gone down again. And today, in fact, I know that in US it is discouraged because many startups who are producing green energy, if they want to put that energy into the grid, then they have to invest more to support the infrastructure that will require to expansion of the grid. So, if you ask a green energy developers, sort of innovators, to spend more money, they will already invest their money in the innovations, but then even in this put in the grid, if you ask them to put more money, then that will discourage them to produce, and that is what is happening, and this is happening in many parts of the next world. So, in other thing that we are doing is also we are promoting conflicts rather than peace. So, and these conflicts are actually using more energy, wasting a lot of energy, which again we are going to supplement by the fossil fuels, right? Then we are putting more and more. Think about the Ukraine-Russia war. For 2-3 years, this war is going on, and West is supporting this because their defense industry is making money out of this. Because of that, they are supporting. And what we are doing, we are demolishing, and we are using all those ammunitions which required so much to produce, and that is all gone. Then we have annihilated towns and villages and countries, and that has to be rebuilt. All that is going to be putting that much more carbon dioxide into the atmosphere, and therefore it is this sustenance of such conflicts around the world is making the sustainable development is impossible. So we cannot do that. There must be serious effort to do this. And instead of that, in fact, because of this, now every country who were investing less on defense are now going to invest more on defense. then again use that much energy to create those defense equipments and defense and so on and so forth. So this is a very unsustainable global situation, and we unless we change that, and but remember that this is essentially to support our development model. That development model, GDP growth model, is what is driving all this. So you have to change that, and that is, unless you change that, I think sustainable development is not possible. Next. Next. So there is actually some possibility why the sustainable. There are many arguments why sustainable development, the GDP growth model are not sustainable, because it increases inequality, it promotes over exploitation of the natural resources. So therefore, these two are sort of, I think, the most important reason why we have to go away from GDP growth model. Next. So early days, actually, GDP growth model was okay in the early days, because at that time the industries were producing jobs. Because now this inequity was not that bad those days, because it created jobs. A lot of people, the per capita income increased because there are more jobs. But on the other hand, in the recent times, because the industries have become more dominated by automation and AI. As a result, there are very few jobs created, but the profits are made by the smaller number of people. So therefore, this is what is unsustainable today. So today, but we are promoting still this AI thing, and then we are thinking that we're saying that, okay, new jobs will be created. How many new jobs will be created? It is not going to be created, and then only fewer people will make more money, and that is again an unsustainable model of development. Next. And all these things are actually and we are forgetting something, that in this whole GDP growth model, every country is still thinking that, okay, we are arguing, actually, including India, we are arguing that, okay, we need growth because we'll create more jobs and people will the middle class will expand and so on. But I think this is not happening, and is not going to happen. But we are forgetting something, that if we don't go away from this, the system itself, the climate change impact itself will force us to change. And that is, these many studies have shown that the climate change impacts are contributing to the loss, socioeconomic loss, which could be as large as 10% of the GDP if by the end of the century, when temperature will increase by about 3 degrees. And even in India, we can expect up to about 10% of GDP loss yearly due to the climate change impact. But I think we are not simply factoring them into our growth model, and we need to factor them. And even today, I think it is happening at least more than 1%, 2% loss is already taking place, but we are not factoring them correctly. We are sort of ignoring them. So I think we need to think that seriously. So several studies have now done this calculation. Next. So in the recent times, in fact, we have understood one serious problem about. I'm sorry, how much time I have? I'll finish in about 5 minutes, maybe. Is it okay? 5? Hello. Hello.
Yes, sir.
Yeah. No. How much time I have? I want to spend about 5 minutes more, and then maybe I can take questions. Okay. Can you? Hello. See, okay. So one of the things that we have discovered recently, that in India we may be seriously affected by the climate change impact from heat stresses increase. We have recently seen a study that it's still not published, that if we looked at the number of days that the heat stress exceeds critical value of about 45 degrees feel like temperature, because if you have more humid heat, it is the humid heat stress that is going to create a more problem, because our monsoon season is long, and during that time the air temperature may be low, but the humidity is so high that your body feels like more than 45 degrees, 50 degrees. And that is when, if you keep working, it affects your physiology and your productivity goes down. And so in fact, you're not supposed to work if this humidex or the feel like temperature is more than 45 degrees. Outside workers are not supposed to work or work under supervision, but we are not even giving those kind of advisories today. And so therefore, there is a potential loss of productivity and increase in the medical cost. And this is happening very rapidly, because from about 1920s until 1920s, this is an example from Guwahati, where I am here, and we used to have over the season of May to September, about 20 days out of the season, it is used to exceed this level. So therefore, but it rapidly, from about 2000, it rapidly increased to about more than 100 days today. Today, we have more than 100. In fact, we are just now going through an extended period of almost 2 weeks of above critical value heat stress conditions. And this is very serious. And we have looked at this in the global next. So if you look at the country as a whole, if we see, and globe as a whole, how this, if we consider that we call it a potential productivity loss. Suppose if I multiply the number of hours lost due to this due to the humid heat stress exceeding 45 degrees over the whole country, and multiply that with the working population between 25 and 60, then that number is hours lost, potential hour lost. And that potential productivity loss, we call it a potential productivity loss, has exploded from again 1920s onwards. Up to then it was reasonable. Then suddenly it exploded, started increasing exponentially, and that increase is from 25 times it has increased from about level of 1990 to today. And this is India, and this is global curve. This is India contributes to about 50% of the total potential productivity loss, because of our working population, and we have so much potential loss is going to take place, and therefore that is going to affect the economy, and we need to really factor this into our economic development model of development. Next. Next. And this is happening because so interesting thing is that this is how these are the regions globally. We have looked at how it is changing, and this is the region. Some parts of the country it is not affected so much, but we are in the northeast and the Himalayan belt and the western part and this part. And now it is in central India also, it is in affecting, and this change is very large. Some part of the country like Goa, etc., is not so much affected because of the ocean currents in this region produces cooling, and that cooling is Goa and Mumbai are saved, but Calcutta, Guwahati, and Dhaka, for example, and northwest is very bad. So country is going to lose a lot of working hours, and that will have an effect on productivity. Next. So what is the alternative? Alternative is something called the degrowth or post-growth model, and there is a lot of studies now and saying that we should not think about the growth of economy is not necessary to create wealth. It can maintain at the same level, but if you have a different model of growth which can still produce enough So main point is that I think the equitable distribution of wealth. So that is what is required. A model of development which will create more equitable distribution of wealth, and that will then also government will also will generate enough revenue, because more people will have more number of people will have disposable income, and that will then consume, and therefore but the point is that will require the big people, the few big people to not to. There has to be restriction on how the richest can earn how much money, that kind of a thing. So therefore, there is some issues are there. So whether it is possible or not, I don't know. But there is, I think, there's talk going on next. There are studies, several studies are arguing this and written about it. And there is discussion. In fact, Japan did this over the last several years. But because of all these conflicts, again, they are going back to this arming themselves. They did not invest enough lot of money on defense, and they used the kind of degrowth model. They did not. Their model of development was not like the rest of the developed countries, but they are having other issues today. But I think this is something that needs to be, should be considered, and alternative next. So what we need to do is essentially we need to cut down energy demand. Without cutting down energy demand, I think we could never be able to because the rate at which we are increasing the green energy availability is increasing is far too slow compared to the rate at which energy demand is increasing. The total energy demand is increasing. It cannot go on. So we have to change unless government puts or the private and government puts lots of investment to generate green energy very fast. Unless that happens, which is very unlikely, then we cannot continue this. So this is the dichotomy, and that is what is how do we solve this problem, and that is. My suggestion is that we have to, I think we are too much dependent on the big techs, and big techs are controlling all the government policies, and that is what is. So we have to get away from that, and instead we should go back to supporting the MSMEs, the small and medium range, medium scale industries, so that they create much more jobs, and their profit may not be, the industry as a whole, their profit may not be very high, but the workers will be, so there is equitable distribution of the wealth in that case. On the other hand, this big tax, very inequitable distribution of wealth. And so that needs to change. And so, and we need to probably also have some regulations on how AI is going to see, for example, we are spending so much energy, energy in Bitcoin. Now we are promoting Bitcoins all over the world as a big thing, and then how many people are benefiting there? Very few. But how much energy it is consuming? Huge. And that energy is only benefits very few, and there is very big, very poor distribution of wealth again, and that leads to again inequitable growth. And that is what we need to. These are some things that we need to change. Okay, next. And so the geopolitical changes are actually is a very big concern. The changes in the geopolitical scenario, like the US today happening. So big techs are actually openly coming and trying to control the government policy. Also, it always controls from behind, but today it is not even that. Now today it is openly coming, like Elon Musk coming and completely controlling. Of course, that is changed in the recent days, but still it is that is the See, for example, the policies like government, there are economists are saying that the government should cut down government investment in the public, so everything should come from private. But the private does not have the private industries do not have the welfare of the public in mind, right? The government has to have, and then they are not investing innovations that will be required to solve this problem. They will invest only on how to improve their bottom line, but not to solve this problem. And that has to come only from government. And the government, if it doesn't invest that, then we have a big problem. So in fact, the economist says that if we just slash the federal enterprise, Robert Atkin says at the end of the day, we are going to get less innovation, not more. Next. The geopolitics has changes in a way that is again not sustainable. The different foreign policies, etc., etc. These are all going to put more on spar in defense funding and increase in carbon dioxide and decrease in the green energy evolution, which is the total opposite of what we require. Next. So finally, I think this is, I say that it reminds me of a famous saying by Mahatma Gandhi, says that art has enough for everyone's needs, but not for everyone's greed. And I think it is a greed of a select few in the world today is causing the problem for the rest of the world, and unless we can change this, we have a serious problem. The problem is how to start the change. Who will get the bell? Which country will start a degrowth model, for example? This is going to be very difficult because the public is unaware of these problems in a way, and the government narrative are generally not in that direction. As a result, and the government don't want to do it because then their funding may be the sustenance may be at risk. So these is a serious problem, but probably there may be, and the global regulatory organizations have failed, and UN cannot implement anything today. As a result, we have more problems. So we cannot come to something that will be equitable for. Nobody thinks about how the sub-Saharans, the least developed countries who contributed nothing to the global climate change are most affected by this climate change, should be supported, but not being supported by any of these. But so these are issues that needs next. So unless, of course, there has to be a global social revolution. That is why I think I am talking about this, because I want to, in this audience, I know there are economists, there are social scientists. So I think we all need to educate the common people about these problems and the hypocrisies of these policies, so that people can come out and change the policymakers and tell these policymakers that, okay, we don't want this, we need different policies, and then only it will probably change. With that, I'll stop. Thank you very much, and I'll be happy to take some questions.
Continue. Yeah. So, thank you very much, sir, for your elaborative talk on global warming.
Thank you.
This our climate due to climate change. What all the challenges entire global world has.
Yeah.
Informative on brainstorming session you had given us to all of us. On behalf of KSCST, we thank you very much for your interactive brainstorming session, sir.
Thank you. I just want to make one more point, comment that the sustainable development also must be what you call a just for inter-regional justice, and just intergenerational justice. For example, we must do today what we do are going to affect our grandchildren and the next generations, right? So we have responsibility, but that justice we are never considering, and I think we need to consider those. And similarly, inter-regional justice must be factored in, like the developed countries. Developed countries are more responsible for the climate change problem. Least developed countries are not. But then, what is this? How do we put the responsibility in a just way? And that is also not happening. So these are issues I think also need to be considered. Thank you.
So thank you, dear students and faculty members and my colleagues who are online today. We have come to the end of today's webinar series on the occasion of Golden Jubilee celebrations of Karnataka State Council on the topic climate change and sustainable development. And first and foremost, I thank Professor Ashok M. Raichur, our Secretary of KSCST, for his program overview and initiating this monthly webinar series. Thank you very much, sir. So I also thank the first speaker, Professor Lakshmi Narayan Rao, from Sustainable Center for Sustainable Technologies from IAC, was given a elaborative talk on integrated water management, what are all the seriousness of water management in Bangalore and the effects of the environment and so on. So I thank Professor Lakshmi Narayan Rao for this in this occasion. And I also thank Professor B.N. Goswami, Honorary Professor of Excellence, Guwahati University. Sir, you have enlightened a lot of information on global warming, climate change, what all the exponential growth of energy consumption, what are all the effects. A lot of information you have given us. There are a lot of challenges we have, thinking we have to contribute, each one of us, here from the society side as well as the nation side. A lot of things we have given, enlightened us. Thank you very much, sir.
Thank you.
Yeah. So again, dear students and faculty members, again, we will come back with a new topic on the occasion of Golden Jubilee. Every month we are, this is the 6th topic on the webinar series, and we will come back to you with a new topic and informative interaction session in the month of August. Thank you, one and all.
Thank you.
Thank you.